The first question asks us to find the model that shows the fractions 1/3 is equivalent or equal to 4/12. So we could prove that using a mathematical equation. To get from 3 to 12, I'm going to need to multiply times 4. 3 times 4 equals 12. And if I do the same thing, if I multiplied my denominator by 4, I have to do the same to my numerator. So I'll do 1 times 4, and that equals 4. So we've proved that that's a true equation. Now I need to find the model that shows 1/3 is equal to 4/12. So if I look at option 1, there's 1, 2, 3 equal size pieces in the top model, but 2 of those are shaded. So that shows 2/3, not 1/3. I know that can't be the correct answer. If I look at option 2, there's 1, 2, 3 equal size pieces. One of those is shaded, so that does show 1/3. The bottom, there's 1, 2 pieces shaded. In the whole, there's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's broken into 12 equal size pieces. So we have 2/12, and I can see that the amount shaded in this bottom model is not the same amount as what's shaded in the top. So option 2 is not correct. Option 3 can't be correct either, because we can see that there's more shaded in the bottom than there is at the top model. So here there's 1/3 shaded, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 6/12, or 1/2 of that is shaded. And those are not equal. Option 4, I have the same amount shaded. I can see that the top model and the bottom model both have the same amount. In the top, there's 1, 2, 3 equal pieces, and one of those pieces is shaded, so that represents 1/3. And in the bottom, there's 1, 2, 3, 4 pieces shaded. My numerator is 4. In the whole, there are 5, 6, 7, 8, 9, 10, 11, 12. So that's 4/12, and that model shows that 1/3 is equal to 4/12, just like we proved using multiplication at the beginning. Okay. Next, we're looking for the model that correctly represents the problem. So on the first one, we have 7/8 plus 5/8. My denominators are the same. I'm adding 1/8 size pieces, so I'm ready to add. 7 plus 5 equals 12/8. 7/8 plus 5/8 is equal to 12/8, not 11/8. If I go over to the next one, option 2, 7/8 plus 5/8. My pieces are 1/8 size pieces, so my denominator stays the same. 7 plus 5 again is 12, not 9, so option 2 is incorrect. If I go down to option 3, I still have 1/8 size pieces. So 7/8 plus 5/8. My denominator stays the same, and I add the numerator. 7 plus 5 equals 12. That is 12/8. And they're saying 12/8 equals 1 4/8. So we'll see if that mixed number's right. I know to make a whole, I would need 8/8. And if I have 12, from 8 to 12, I would have 4 pieces left, so that would be 4/8. So our mixed number is correct. We just need to make sure that the model correctly represents that. So we're going to make sure we have 7/8. 1, 2, 3, 4, 5, 6, 7. There's 7/8. And we need to add 5/8 to it. There's 1/8, 2/8, 3/8, 4/8, 5/8. So the correct amount is shaded. 7/8 plus 5/8 equals 12/8, which is equal to or the same as 1 4/8. You can also see that 4/8 is equal to a half, so that would be this also equivalent to 1 1/2. Next, we need to find what A, B, and C are equal to in this area model. Okay, so we have A times 45 equals 1,665. So I know that my long side here is 40 plus 5, so multiplying 45. And then the other side that I'm multiplying, I have 30 plus something, but I'm not sure what that missing number is going to be. So we're going to have to find what that is. Okay, so let's just go ahead and start with what we know. To find C, I know that I will need to multiply the length times the width. So I'm going to multiply 40 times 30 to find the area of section C. 4 times 3 equals 12, and I have 2 zeros. So C is going to be equal to 1,200. They already gave us the area of this section, which is 150, but they found that by doing length times width. 5 times 30. 5 times 3 is 15, and we have 1 0 to add. Now I've got to figure out what B is equal to. To find B, we have to do length, which is 40, times B, which we don't know, and that equals 280. To find the area of the final section, we would need to do length times width, so 5 times B, which we don't know, and that equals 35. So I can use either one of those to help me find the value of B. I know that 4 times 7 equals 28, and if I add a 0 to that, then that would equal 280. So B is going to be equal to 7. Let's check it on this last one to make sure that's correct. 5 times B, which we think is 7, 5 times 7 equals 35. So that is correct. So we know that B is going to be equal to 7. So we found C is equal to 1,200. We found that B is equal to 7. We need to still find the value of A. Well, to find the value of A, I need to know what 30 plus 7 is, and that's going to be 37. So A is equal to 37. B is equal to 7, and C is equal to 1,200. So 37 times 45 equals 1,665. And I can prove that's true by adding all of my partial products together. 1,200 from section C, plus 150, plus 280, plus 35. If I add all my ones, that would be 5. If I add the tens, 5 plus 8 plus 3. 8 and 3 make 11. 11 plus 5 is 16. So I put my 6, regroup the 1 to the hundreds. 1 plus 2 is 3, plus 1 is 4, plus 2 more is 6. And if I add my thousands, I only have 1. 1,665. So we are correct. For the next problem, we're using the commutative property to solve. Remember, the commutative property tells me that I can move around the factors or the numbers that I'm multiplying. It doesn't matter what order I multiply, I'm still going to get the same thing. So I need to show in this first line, that's all I'm worried about right now, is this very first line here. I'm showing that 5 times 3 is equal to or the same as what number times 5? So if I'm trying to make them have the same value on both sides, I have 5 here, I have 5 here, so what's missing is 3. A is equal to 3. Okay, so now I'm going to go down to my second line, and I'm going to solve what's on the left side of the equal sign. 5 times 3 equals 15. So B is equal to 15. Now I'm going to solve what's on the right side of my equal sign. I'm going back up to my first line here. 3 times 5 equals 15. So B is equal to 15 on that side as well. Remember, on both sides of the equal sign have to be the same. A is equal to 3, and B is equal to 15. And then for the last question today, it says to select the diagram and answer that matches this problem. At the bake sale, Ben sold 5 times as many cookies as he sold brownies. If he sold 30 cookies, how many brownies did he sell? At the bake sale, Ben sold 5 times as many, tells me to write the multiplication symbol, and that represents the cookies. That's 5 times is the amount of cookies as he sold brownies. If he sold 30 cookies, how many brownies did he sell? So, reading that again, at the bake sale, Ben sold 5 times as many cookies as he sold brownies. If he sold 30 cookies, how many brownies did he sell? Okay, if he sold 5 times as many cookies, that's going to tell me that he sold more cookies than he did brownies. So I'm looking for 5 times what number, which is we'll use a B to represent brownies, equals 30, because that's how many cookies he had sold. So I know that 5 times 6 equals 30. So B, or the number of brownies, is going to be equal to 6. If I look at option 1, I know that it's not correct because it says he sold 6 cookies. But the story problem tells us he sold 30 cookies. So that one's not correct. On the next one, option 2, says he sold 6 brownies. Okay, so let's look at the model and see if it's correct. It says 24 divided by 4 equals 6. That doesn't have anything to do with what happened in our story problem, because it tells us that he sold 5 times as many cookies as he sold brownies. There was no 4 in that, and there is no 24 for the number of cookies that he sold, so that's not correct. If I look at option 3, it says that he sold 6 brownies. We found that to be true up here. We started with 30 cookies and divided it by 5 and said that equals 6. Let's look at the equation that we wrote. We said 5 times something, the number of brownies, is equal to 30. If I make that into a division problem, I can take the total number of cookies, which was 30, and I can divide that by 5, because that was 5 times as many. That would tell me how many brownies he sold. And that does 30 divided by 5 is equal to 6. So option 3 is correct. Let's go ahead and take a look at option 4. Option 4 says he sold 6 brownies. We found that B equaled 6. But the equation that they gave us is 18 divided by 3 equals 6. And there was nothing in our story problem that told us that he made 18 cookies or that he had sold 3 times as many cookies as brownies. So that does not match our problem. Option 3 is the correct answer. Make sure that you get all of your work done today. You have another assignment, which is practicing multiplication by 1-digit numbers. And on your directions, I tell you to make sure you bring in your scratch paper tomorrow. So don't forget to do that. I want to see how you worked out your problems. Remember that you can use the area model if you're not sure of another strategy to use. Everyone's pretty comfortable using the area model. So use what you know to help you. Let's go ahead and work that first problem together from your multiplication practice, just to kind of have a refresher on what to do. I'm going to add another slide here. All right, so the first question is 478 times 6. So I want to use an area model. To do that, I'm going to break 476 into expanded form. So I'll have 3 sections on my long side. My longest side is going to have a value of 478. And it's going to have 3 sections. So that'll be 400. The next section is going to have a value of 70. And the last section will have a value of 8. Go ahead and split those sections. And I'm multiplying by 6, so my short side is going to have a length of 6. To find the area of this first section, we'll do 400 times 6, 4 times 6. I'm going to add my 2 zeros. To find the area of the next section, I'm going to do length times width. So my length is 70 times 6. 7 times 6 is 42, and I need to add a 0, so that will be 420. And to find the area of the last section, area equals length times width. My length is 8 times the width is 6. So I'm going to multiply 6 times 8, and that is 48. Now I need to just add those together. So 2,400, 420, and 48. I'm lining all my place values up. I have 8 ones. In the tens place, I have 4 plus 2, which is 6. In the hundreds, I have 4 plus 4, which equals 8. And the thousands, I just have 2. So the answer to your first problem is going to be 2,868.